Okay, so here's our lesson on solving simple exponential equations. Exponential equation meaning we're going to be solving an equation where our variable x is in the exponent, and we have to find the value of x that makes the equation true. For today's lesson, we need to remember two exponent properties that we've probably learned before. I'm going to start with the one on the left, the property of equality. Now, this one you may not have officially learned before, but I think that as you see it written, I think you'll be able to fill in the blank of what this property says. So I've set up the first part for you. This property says that if b to the x equals b to the y, then what do you think would be true? So I want you to notice that what I'm saying here by using b on both sides is that the base is the same on both sides. So if I have something to the x equals something to the y, what would have to be true? The thing that would have to be true is that x would have to equal y, right? If the base is the same on both sides, you have a power on one side, another power on the other side, and the base is the same, then it would make sense that the exponents would have to be the same. So we're going to use that one today a lot. And then the one on the right, power of a power property. So this is going to come up today. This means you have a power raised to another power n. So a to the m raised to the n power. And you learned at one point in Algebra 1, when you learned all your exponent properties, that this means a to the m times n. So when you have a power of a power, you multiply the exponents and you keep the same base. That's what you've learned in the past. We may use our negative exponent property today as well, but we've already kind of talked about that one this unit, so hopefully as it comes up, we will know what to do. So moving right along, so we're going to draw from those two. So in example 1, we're being asked to solve 8 to the 3x minus 5 equals 2 to the 11 minus 4x. And so just a reminder, we're trying to find the x value that would make this statement true. So I'm going to give you some pretty clear steps, so I don't want to waste your time. So step 1 is we want to be able to use the property of equality. So our goal is to make both sides be a power of the same base. So we're going to rewrite both sides as a power of the same base. So right now we have a base of 8 and we have a base of 2. Now I said both sides. I'm going to kind of amend that to say one or both sides. One or both sides. So you may not need to rewrite both sides, but you want to look for what is there that they have in common. 8 versus 2. Is there a common base there? Can I rewrite one in terms of the other, like as a power of the other? So what I notice here is that 8 is the same as, I know that 8 is the same as 2 to the third. So I'm trying to look for a connection between the 8 and the 2 and rewrite one of them in terms of the other. So I know that 8 is the same as 2 to the third. I have a 2 on the right side. So I'm going to rewrite the 8 as 2 to the third. So what I'm going to do is I'm rewriting the 8, but I'm not changing the exponent. So what I'm going to do is, because I'm rewriting the 8, I'm going to put it in parentheses, like that. I'm going to put that part in red. And then I'm going to bring down everything that I didn't change. So 3x minus 5 is the exponent. And the right side is 2 to the 11 minus 4x. So in this case, I rewrote the left side so that I rewrote 8 as 2 to the third. Now, I have not changed anything, right? This is still 8, still equal to the 8, which means this is still exactly the same as what it was before. It's just looking different. So now I have an exponent on top of another exponent. That is exactly the power of a power property. So once I've rewritten it, then I need to simplify my exponents. I have an exponent now on top of another exponent. So what I need to do there is multiply the exponents together. So I will do that. So my base is going to stay the same because that's what this property says, is the a stays an a. So my 2 to the third, I'm going to take the 3 and multiply it times 3x minus 5. Now, if you multiply a number times a binomial, we need to distribute that. So this is going to become 9x minus 15. So I distributed 3 times minus 5. And on the right side, I'll have 2 to the 11 minus 4x because I haven't changed anything. So step 2, I simplified. In this case, I used the power of a power property. Okay, and so this is my goal. Just if we go back up to our properties, my goal is I want to be able to use that property of equality. So now on both sides, I have a power of the same base. If 2 to the something equals 2 to the something else, those 2's are the same, so then that must mean the exponents are the same. So now I can take my exponents and set them equal to each other, and I can take the 2's out of it. So what I'm setting this equal because I know that regardless of the power, as long as the base is the same, then the exponents would have to be the same. So I can ignore the 2's and set the exponents equal. And now I just have to solve the equation that I've written. So I want to get x by itself on one side, so I'll add 4x to both sides. 13x minus 15 equals 11. And then I'll add 15. That gets me 3x equals 26. 13x equals 26. And then I'll divide by 13. Got x equals 2. Now, just for this, the purposes of this one, I don't necessarily expect you to do this every single time, but for this one, I'm just going to check this one. You can check anytime, so if it's a test, you can check your answer by just plugging your answer in. So my problem was 8 to the 3x minus 5 equals 2 to the 11 minus 4x, and I got 2 for my x, so that gives me 8 to the 6 minus 5 equals 2 to the 11 minus 8. 8 to the first equals 2 to the third. And that makes 8 equals 8. So I can see that this is the correct answer. Okay, so these are going to be your steps. You're going to want to rewrite both sides, one or both sides. In this case, I only had to rewrite one side as powers of the same base. Simplify. So in this case, I had to use the power of a power property. Set the exponents equal, and then solve. So go ahead and take a look at this one, see how it may be the same or different, and go ahead and give it a shot. Maybe pause the video and then unpause it. All right, so I'm going to go about it the same way. Step 1, I want to rewrite both sides as a power of the same base. So I want to look at 81 and see, can I rewrite that as 27 to the something? I cannot. 27 to the first is 27, and 27 squared is something really big, because 27 times 27 is really big. So can't rewrite 81. I can't obviously rewrite 81 to make 27, because 81 is already bigger than 27. So my goal here is to see if there's some common thread between the two. So 27 and 81, they are both powers of 3. So in this case, I'm going to rewrite both of them. 27 is the same as 3 to the third. So I didn't change anything again. 3 to the third is the same as 27. I brought everything else down. I just rewrote 27. 81 is the same as 3 to the fourth. And if you don't know these, you're going to get to know them better the more the time goes by. But I didn't change that. I just rewrote it. You can use a calculator if you don't know those values, but you may have to play around with the calculator a little bit. So now I have two sides, both in terms of 3, and I'm going to use my power of the power on both sides. So I have an exponent on another exponent. I need to multiply those exponents. So that's going to make 3 to the 15x. 3 times 5x is 15x. And then over here, just be really careful. Again, I have to distribute this. So I'm going to do power of 3. 4 times 3x is 12x. 4 times 4 is 16. Okay, and then again, I have a base that is the same on both sides. So if 3 to the something equals 3 to the something else, then the somethings must be equal. So I can just set 15x equals equal to 12x plus 16. So it's not that I'm getting rid of the 3's per se, it's that I get to ignore them because I know that if the 3's are the same, then the exponents have to be the same too. That's what our property at the top says. And then I can solve for x on this one. So minus 12x. X equals 16. Divided by 3. And this isn't going to throw me because it's okay that 3 doesn't go into 16. It means I have a fraction. It's my answer here, 16 over 3. Don't get in the habit of saying no solution or can't be solved. Like, that's a number. It is the number that solves this. It's just not a whole number. Okay? And we'll do one more. Okay, so solve 1/9 to the x plus 2 equals 3 to the x minus 1. Take a second and think about this one and how you're going to handle this. We have obviously a fraction on the left side, power of base 1/9 on the left side, a base 3 on the right side. So I would need to think about what power do these two things have in common. So thinking about exponents and what type of exponents do certain things. Obviously I have one thing that's a fraction and one thing that's a whole number. So you have to think about what kind of exponent changes something from being a whole number to a fraction. And hopefully you're remembering negative exponents. So remember that a negative exponent makes a fraction. So we know that a to the negative n makes 1 over a to the n. So if you can bear with me, I'm going to rewrite 1/9 as 3 to the negative second. 3 to the negative second. I know that 9 is 3 squared, but this is 1/9, so that must mean it's a negative 2 instead of a 2. So using this example to remind you about negative exponents, 3 to the negative 2, just like I have up here, would give you 1 over 3 squared, which is 1/9. So again, I haven't changed it. It's still 1/9. I just rewrote it as a base 3. And now I can multiply my exponents. Power of a power property. And now I have the same base. And so I can set those exponents equal. Negative 2x minus 4 equals x minus 1. I can subtract x on both sides. I can add 4. And I can divide by negative 3. Okay, so those are 3 examples of how we can solve a simple exponential equation. Now note, I'm going to just kind of explain now that we've done these, why these are simple. They're simple because I can solve them just by rewriting powers, and obviously it has something to do with the fact that I can rewrite as powers of the same base. So for example, if this hadn't been a 3, I would have been in trouble. Like if this had been a 5, I wouldn't have been able to use this process. So you're going to be experiencing things where it's possible to follow these 4 steps. And so the first one being the most important, starting by rewriting as powers of the same base and then working from there. Okay, that's it.